Before testing, there are a couple things that we should do. If we look at our board carefully, we want to inspect it and make sure there aren't any issues. For example, if I take a look at the board where the display is soldered on, where'd it go? There we go. Those leads are kind of long. And if these happen to touch because they're connected right across the power, it could cause a short circuit. So I want to trim those leads shorter. I also want to make sure there aren't any little bits or pieces of wire that are still attached that are not that could potentially short out. Also, you'll notice something there. There's one wire that has not been soldered even though I clipped the lead on it. A connection like that could cause a problem where the whole power supply doesn't work. The board itself also looks a little bit messy because the flux tends to leave a little bit of kind of some residue on there. I'll show you in a second how we take care of that, but first I'm going to solder that connection. So if you look at the bottom of the board, you'll notice that it looks kind of dirty. That's basically the flux that's left on there. It doesn't really cause problems, but if you had little bits of metal that could stick to it, it could be problematic. Most circuit boards need to be washed in isopropyl alcohol to clean them off, but the solder you have is a little bit different. If you use the solder from the kit, it actually uses an organic flux that can be cleaned off with regular water. This is kind of different, not very common. To do that, I'm simply going to get a toothbrush. I'd use an old one, not the one you brush your teeth with, and simply scrub it. And you'll notice when you scrub it, it kind of bubbles up a little bit. You have to do this for a little bit and then rinse it off. Now that may seem like the weirdest thing to actually rinse off electronics, but if it dries, you'll notice that it's actually cleaned off almost all of the flux. Now before you power your board, you have to make sure it's completely dry. So dry it well, or you can even use a hair dryer to dry it off or leave it outside overnight. Okay, we're now at the point where we can actually test the power supply almost, but we need to wire up the power connector. I'm going to use some yellow wire, about 3 to 4 inches long. It's 22 gauge, so I'm going to insert it in the 22 mark and strip the end like that. Once the wire is stripped, we're going to bend a little hook in the end of the wire. And carefully hook it into one of the looped ends on the connector. This is a little tricky to do, but it should look like that. And then we'll solder the wire. You can use this with, you can solder either solid or stranded wires. In this case, I'm using a solid wire. Next, I'm going to twist these wires together and strip the ends about 1/4 of an inch each. Once I'm done with that, I'm going to screw these into the end wires on the terminal blocks. You know, when you place it into the terminal block, the wire should not be sticking out very far. They should be fairly close to the end. If the wires are stripped too long, they can short out. But you don't want them so short that inside the connector, they're not actually making a connection. The adapter we're using is an AC adapter. We'll talk a little bit about how this is actually used in this application a little bit later in the week. To test it, I'm going to plug in my adapter and connect it to the power and see what happens. Okay, plugging it in now. So you'll notice the green LED came on, and the display there is reading 9.59 volts. Your LED display is probably going to be potentially a different color because they've got a few different types. One of the things we need to do to test it, though, is to also check the voltage on the outputs. So this output here is set by this variable resistor. It goes up to about 16 volts. If you get down too low, down past about 2.5 volts or 3 volts, the display starts to fade. But that's because the voltage regulator only puts out that voltage. In order to test the power supply, we need to be able to connect wires to those terminals. I think in the last little clip I showed you that this is a variable output, and this is fixed at 5 volts, so it's a dual output supply. So I'm going to connect a resistor. I'm going to connect wires to the terminal blocks, making sure not to short them out. Screw down the wires. And then I'm going to connect a voltmeter real quickly to see if that voltage matches up. So I'm measuring 4.93 volts, 4.94 volts. So that's pretty close. If I check the 5 volts, I'll do that in a moment. One of the important things is, again, make sure that you don't short these leads out as you're testing them. The only reason I'm putting the resistor on here is so that I can get to the pins fairly easily. Okay, so now I'm going to test the 5 volt supply and see what it looks like. You'll notice there's no display for the 5 volts, so it's 5.08 volts, which is fine. I can adjust this voltage higher too. There might be a little bit more of an error because we have a little bit of rounding there in the display. Okay, but there I'm measuring 10.65 volts. These little DMMs, digital meters, are not super accurate, so don't expect them to be super close, but they can get you pretty close to the actual output voltage. The next step is building the enclosure. To do this, we're going to start with the base piece, which has the 4 holes drilled in it. They're located in the bottom left corner of the board. I'm going to use these devices called standoffs. Basically what they are spacers, a 1/2 inch long, that are threaded for screws so that we can mount the circuit board inside the box. If I push a screw up on the top, or from the bottom rather, I can screw this in place. And to start with, don't tighten it down all the way. The reason why is that there's a little bit of slop in these holes, and it might be hard to try to get the circuit board on there precisely. I'm going to go ahead and do the other ones now. So we'll use 4 of the same size screws to mount the board in place. And you'll notice in this case that 3 of them line up really close, but the last one doesn't. That's why I was saying to leave the screws on the bottom a little bit loose. That'll allow everything to get lined up nicely. So I'll screw those all down with a screwdriver. So now those screws are tightened down and holding that board in place. The next step is we're going to be mounting these terminal posts, which can be used, they're called 5-way plugs. You can insert wires in them. You can also plug in banana plugs like we have for the lab power supplies. What we're going to do is mount these on these little end boards. What's important in this case is that I'm going to loosen up the screw here, place the red one where it says 5V there, a little hard to see, and another red one where it says V+. I'm going to put the nut on the other side and tighten it down. Now once that's done, I still have to attach wires to the posts. I'll show you that in the next step. If I can get this on here. I think I've got the wrong nut. No, there we go. Okay. Okay, now I've got these 4 binding posts on here. You'll notice that the ground terminals are black and the positives are red. You can use the pliers here to tighten up the nuts on the back to make sure they're nice and snug before you go on. Once the box is closed up, it's a little hard to get it open, so you want to make sure these are all tight before you continue. The next step is we're going to attach wires onto the ends of these posts to attach to the terminal blocks that are there on the back of the power supply. The next step is attaching wires to these binding posts. So I'm going to start with 22 gauge wire. Everybody should have some lengths of this that are red and black. Strip the end, and I kind of twist it into a little hoop. Once that's done, I'm going to slide it over that post. Try to do this with one hand here. And then screw down the nut and hold it in place. And I do that for all 4 of the wires. Black wires on the black terminal post, red on red. When you attach these, you want to make sure that you tighten the nut on the end. And keep the wire pressed down so that it squishes the wire between the 2 nuts. Alternatively, you could try soldering on the ends, but you typically need a pretty high wattage soldering iron to do that because the post is pretty thick. I only have one of these shown right now, but you'll connect all 4 of them. The next step is to take that wire and insert it into the terminal block. You want to make sure too that as you tighten the terminal block, that it doesn't cut into the insulation, but the wire is going in far enough for it to actually connect. So once that's in there, I'm going to screw that down to tighten it. Okay, so I've got all 4 of those connected. You'll notice I put little hoops on the wires. That just makes it a little bit easier as you're attaching it. If they were just straight wires, it'd be a little difficult to connect it. But they almost act like springs and allow you a little bit of distance to make the connections. Again, you want to make sure that where the wires are in the terminal blocks, that it's clamping down on the wire and not the insulation, and that the wires aren't stripped too far back. If they are, it could short the wires out to the adjacent terminal. The next step is we're going to take our power jack, route it through, and attach the nut to hold it on the other end. We'll use pliers to tighten that up. And then we're going to basically attach it kind of the same way to these 2 terminals, doesn't matter which one, for the input. We'll see what that looks like next. So now we've finished all the wiring, and you probably at this point understand why I had you test it before we actually put it in the box. If something was wrong, you'd have to disconnect everything. And the same reason why we'll test it here again really quickly before we finish putting everything together. The last thing we want is something damaged and then have to disassemble everything. So if I plug in the power, LED comes on and I can adjust the voltage again. So I'm assuming at this point everything is good. Now to really double check it, you'd want to measure the voltage at the pins on the terminal blocks and make sure that they're still putting out the right voltage. If they're not putting out any voltage at all, double check the connections on each of the binding posts to make sure the wire is screwed in properly and make sure they're connected to each terminal block. Same thing on this side for the AC input. Okay, so the very last things that we need to do are to attach the sides, which are the acrylic pieces. They just slide into place. Put on the top cover like that. Now, you can do one of 2 things. You can glue it into place using some kind of either hot glue gun or some epoxy. I would not use a lot of glue, just a little bit in the corners to hold it in place. The other option is just to tape it in place with clear tape. The reason I recommend that is if there's any problem, you want to be able to still open up the case if there's a problem. The very last thing is there are 4 what are called rubber feet that attach. If you peel those off, they're on a little square pad, and you can put 4 of those. And the whole purpose of those is to keep it from sliding around or scraping up a table because of the metal screws that are on the bottom. Once that's done, your power supply is done. Congratulations. Whoops, almost forgot. We also have a knob that we can put on there. What I do is turn the knob all the way to the right, counter or clockwise, and then put the knob so that the little marker is at about the 5 o'clock position. You have to kind of push it in place, and then that'll allow you to adjust the voltage.